bubble sort is a very basic sorting algorithm. It is also one of the first algorithms that a CS student learns. This algorithm is very simple. In each iteration, we compare two integers, and if we want to sort this array from the smallest element to the largest element, every time we take two elements, then compare and see if they're in the correct order. So since we want to sort the array from the smallest element to the uh, biggest element in the increasing order, so we want each pair to be in the order that the left number is smaller and the right number is greater. So first we compare 2 and 10. So since they're in the correct order, we don't swap them. Then we compare uh, 4 and 10, and since they are in the opposite order, so we swap them. Then we compare 10 and 3, and since 3 is smaller than 10, we swap them again. Then we compare 10 with 12, and since they are in the correct order, we don't swap them. Then we compare 12 with 1, and since they are in the opposite order, we swap them. And and uh, then we compare 12 with 5. So notice that what is happening is uh, the the large element, for example 10, is larger than 2, 4, 3. So 10 has uh, gone past 2, 4, 3. And also notice that 12 is larger than all of these elements, so 12 will go to the rightmost cell of this array after this iteration. So first we compare 12 with 5. Since they're in the opposite order, we just swap them. So 5, 12. Then we compare 12 with 8, and we swap them again. So notice that the largest element in this array was 12, and 12 has gone to the rightmost side of this array. So we can say that this part of the array is sorted because 12, since it is the largest element, it has found its place. So now we just need to sort this part of the array. So once again, uh, so in the previous array, in the previous iteration, we compared these two, these two, and up to the last element. But this time we don't want to compare the last element with 12 because 12 is already sorted. So we compare 2 with 4, it's all right. 3 with 4, so 3 with they're in the opposite order, so we swap them. 3, 4. Then we compare 4 with 10, so they are in the correct order, so we don't swap them. Then we compare 1 with 10, and since they are in the opposite order, so we swap them, and it becomes 1, 10. Then compare 10, 5, and swap them, and then compare 8, 10, and swap them. So notice that we were trying to sort this part of the array, and in this part of the array 10 was the largest element, and it has found its place after this iteration. So at every iteration of bubble sort, the largest element in this array goes to the rightmost cell of the array. So we can say that this part of the array is sorted. So now we just have to sort this part of the array, the left array. So compare 2 with 3, it's fine. 3 with 4, still fine. And 4 with 1. So now we have to swap this. 1, 4. Then 4, 5, it's fine. 5, 8, 8, 10, 10, 12. So notice that in this left array, 8 was the largest element, and 8 has found its place. So we can say this part of the array is sorted. Then we just have to sort this part. So 2, 3 is compared and not swapped. 1, 3 is compared and then swapped. Then we compare 3, 4, and then 4, 5. So since 5 was the largest element, 5 has found its place. So we can say 5, 8, 10, 12. This part of the array is sorted. So we just sort this part. Compare to 1, then if we compare to 1, they will get swapped. So 1, 2, then 2, 3. If we swap 2, 3, I mean, if we compare 2, 3, it's not, they are not swapped. 3, 4, still not swapped. So 4 has found its place. So 4, 5, 8, 10 is um, sorted. So we compare 1, 2, not changed, and 2, 3, not changed. So 3, 4, 5, 8, 10, 12 is sorted. Then I compare 1, 2, and they're still sorted. So 3, 4, 1, 2, 3, 4, 5, 8, 10, 12. This is the sorted array. So if you want to code this, we write some method like int bubble sort. So we have this array, and so the first index in this array is 1, and the last index in this array is a dot length minus 1. So uh, in the first iteration, we compare uh, from 0, we compare 0 with 1, then 1, index 1, 0 with index 1, then index 1 with index 2, and index a dot length minus 2 with index a dot length minus 1. And in the next iteration, we compare, the last comparison happens between a dot length minus 3. We compare this index, the value of this index with the value of this index. So so we need a limiter for our range of comparison. So in the first iteration, we compare a dot length minus 1. So for our comparison starts with the leftmost element, so j equals to 1. J is less than uh, so if we uh, if we say the boundary for our comparison is a dot length minus 1, then j is less than I, j plus plus. So we compare a j with a j plus 1. So if the left element is larger than the right element, we swap them. So after this loop has after all these for loops have finished their work, so then we have the array sorted from the smallest element to the largest element in increasing order. So then we can just return this array, return a. So there are many ways we can implement this bubble sort function. So this is one of the most standard implementation of bubble sort.